Okay, this is a video for Algebra 1 Summer School, Unit 4, Lesson 4, Exponential Models with Percent Change. All right, we've talked in this unit about exponent properties, we've talked about exponential models, and percent change, so now we're going to put those all together. Right, so it says, exponential functions are functions of the general form y equals a times b to the x power. There's no plus and no minus, it's all about multiplication. We've learned that a is the y-intercept, and b we call the growth rate. When the growth rate is bigger than 1, we call the exponential function increasing. This is all review topics here. And when b is less than 1, it's still positive, but it's smaller than 1, we know that that exponential function is going to be decreasing. All right, oftentimes exponential functions have a whole number as the growth rate. Those are the kind of exponential functions we looked at in Lesson 2. In word problems, which we'll explore in Unit 7 of this course, these whole numbers are expressed with the words doubles or triples for increasing functions and halves for decreasing functions. Today we're just going to worry about percent change with exponential functions for just looking at the equation. There's going to be no word problems involved. Okay? So let's start with this example. Remember that if we're going to have percent increase, I'm going to be using 1 plus p and 1 minus the percent for percent decrease. So let's just start by being given a starting rate and writing an exponential equation that grows or decreases by a given amount. So we're going to start by saying that I have an exponential function that starts at 50, which means 50 is the first number you write down, and grows by 20%. Now when it grows, we just said that we're going to write that exponential as 1 plus the percentage, which they told me was 20. So 1 plus 0.20 to the x power. You can definitely leave your equation written like that, but if you want to simplify it, you can write this equation as y equals 50 times 1.20 to the x. It's the exact same thing, just written without the plus sign. All I did was simplify what's inside the parentheses. All right, let's try number 2. We're going to write an equation that starts at 5, so y equals 5, and there's a percent increase of 15%. So that means I'm going to have 1 plus 0.15 to the x. Now if I want to, again, I can rewrite that expression by changing the 1 plus 0.15 to 1.15. Just as a simplified form of the original expression. All right, number 3 and 4 are both going to be decreasing exponential functions. So I'm going to write an equation that starts at 14, so that's always the first number that's written down in an exponential, and is percent decreased by 10%. So I'm going to have 1 minus 10% to the x power. Now, if I wanted to, I could take my calculator and I could figure out that 1 minus 0.1 would give me y equals 14 times 0.9 to the x. Now, we learned in Unit 1 that if my growth rate, 0.9 here, was less than 1, we have a decreasing exponential function. So that's your other visual cue that this is decreasing other than the word. Finally, we're going to write an exponential function that starts at 252 and decays by 8%. So I'll have 1 minus 0.08 to the x. That's what 8% is as a decimal. If I simplify 1 minus 0.08, that is 0.92. So I could rewrite this equation in an equal way as 252 times 0.92 to the x. Alright, so it's pretty simple to write the equation of an exponential function when you're told the growth rate and you're told the starting rate. For these next 6 examples, we're going to be given an exponential function. You need to identify the starting value, decide if it's an increasing or decreasing exponential function, and then tell me the percent change. Alright, so looking at number 1, we have y equals 15 times 1.03 to the x. You should be really good at this point of finding the starting value. That's the first number that you see, which is 15. Now for increase or decrease, because 1.03 is greater than 1, we are increasing. Now to find the percent change, all I have to look at is the number that follows the decimal place. We know it's increasing, so we just take that decimal that's after the 1 and turn that into a number. 0.03 is 3% increase. All right, for number 2, my starting value is 29. When I look at 0.95, that's a value that's smaller than 1, so it's exponential decrease. And finding the percent change this time is a little bit harder. What I have to do is I have to take 1 minus 0.95. That's going to give me the percent that I'm going down by. When I subtract those two, I end up with 0.05, which is 5%. So you're starting at 29 and going down by 5%. All right, number 3. We get a starting value of 100. Because 1.2 is larger than 1, this is exponential increase. And the percent change is just the number that's after the decimal point. 0.2, which is 20% increase there. All right, now we've done 3 examples. There's only 3 more. If you'd like, you can hit pause right now and try those 3 questions on your own. If you need a little bit more support, stick with me and I'll do the last 3 examples with you. All right, for number 4, we get a starting value here of 13.5. That is the number that shows up first in your exponential function. The growth rate is 0.7. That growth rate is less than 1, so it's an exponential decreasing function here. And to find the percent change for an exponential decreasing function, I take 1 minus 0.7. When I subtract those, I end up with 0.3, which is 30%. So this is a decreasing exponential function by 30%. All right, the starting value in number 5, 25.72. Because 0.91 here is less than 1, it's exponentially decreasing. And to find the percent it's decreasing, I take 1 minus 0.91 and get 0.09. 0.09 is a 9% decrease. All right, finally, the starting value for 28.5 times 1.16 to the x is 28.5. 1.16, which is our growth rate, is larger than 1, so it's an exponential increase. And the percent that I'm looking at is just the 0.16, which is 16%. Okay, so let's go ahead and try your practice for lesson 4. The file and the video are all posted on Canvas. If you need any extra help, stop on into office hours to see your instructor.